Welcome to EDU World Space.
We are given the function g of x, which is the integral from 0 to x of the function f of t dt, where f is the function whose graph is given in exercise 2 of this chapter. In part A, we're asked to evaluate the function g for x equals 0, 1, 2, 3, 4, 5, and 6. In order to do this, first, let's look at the figure for f. So I'm going to reproduce a copy of that graph here. We have our x and y axes. The x-axis will range from 0 up to 6, and the y-axis from 0 up to 3. And the graph of f begins at the point 0, 1, goes down to the point 1, 0, all the way to the point 2, negative 1. So I guess y actually ranges down to negative 1 as well. Then goes back up to 3, 0, and continues all the way up to 6, 3. We can divide this up into triangles and rectangles like this. So we have a triangle here. I'll call that triangle A. We have two more triangles here and here. I'll call these triangles B and C. We have another triangle here. I'll call this triangle D. Then we have a rectangle, which is actually a square here. I'll call this E. Another triangle above that, which I'll call F. Another rectangle, which I'll call G. And finally, another triangle, H. Now, as g of x is defined, it is the area between the graph of f and the x-axis. Where we have areas below the axis being negative. Therefore, for example, we have that g of 0, well, this is, by definition, the integral from 0 to itself, 0, of f of t dt, which is just 0. Because the limits of the integral are the same. Now, g of 1, this is by definition the integral from 0 to 1 of f of t. And we see that this is the same as the area of A, which, because it's a triangle, this is 1/2 times 1 times 1, which is just 1/2. g of 2, by definition, is the integral from 0 to 2 of f of t dt, which is, looking at our graph, the areas of triangles A and B added together. Remember that these are signed areas. Well, we saw that this is in fact 1/2 plus 1/2 times 1 times -1. Our height is below the x-axis, and so this is 0. Likewise, g of 3 is the integral from 0 to 3 of f of t. This is the area of triangles A, B, and C, which is just the area of triangle C, which again is -1/2, and so this is -1/2. Likewise, we find that g of 4 is areas of A, B, and C plus the area of D as well, and this turns out to be 0. G of 5, this is the areas A, B, C, and D, plus now the area of E and the area of F. Now, we see that E is a rectangle, and so its area is simply the base times the height, and so this is simply the area of E, which is 1, plus the area of F, which is 1/2, which is 3/2. And finally, g of 6 is the areas A plus B plus C plus D plus E plus F plus the last two areas G and H. And so this is going to be 3/2 plus the area of G, which again, G is a rectangle, so this is going to be base times height, which is 2, plus another 1/2, and this is 4. So those are the values of g for x between 0 and 6. In part B, we are asked to estimate g of 7. Well, by definition, g of 7 is the integral from 0 to 7 of f of t, which, using integral properties, this is the same as the integral from 0 to 6 of f of t, plus the integral from 6 to 7 of f of t. Now, we saw in part A that g of 6 was 4. Now, looking at the area from x equals 6 to 7, there appears to be about 2.2 square units. So this is approximately 4 plus 2.2, or 6.2. In part C, we're asked to determine where the function g has a maximum value and where it has a minimum value. Well, notice that if we begin at t equals 0, from our results from parts A and B, the maximum amount of positive area is added when t reaches 7. Therefore, it follows that g has a maximum value at 7. And this maximum value is, in fact, g of 7, which we saw from part 2 we estimated was about 6.2. Now, beginning at t equals 0, the maximum amount of negative area is added when t equals 3. So it follows that g reaches a minimum at t equals 3. And this minimum is g of 3, which we saw in part A was negative 1/2. Finally, in part D, we're asked to sketch a rough graph of the function g. To do this, we'll use parts A and B. So we essentially have a table of values we can generate from those parts. And from those parts, we see that, well, if we set up our x and y axes, x is going to range from 0 up to 7, and y from 0 up to about, well, 6. And as we saw from part A, we start out at 0, move up to about 1/2, then we start moving down until we reach 0 again at about 2, like this. We reach a minimum value at x equals 3 of about negative 1/2. From part C, we know this. And then from that point, we start increasing like this until we get to x equals 7, where g is about 6.2. We start leveling off there.